People, hope you're doing great today. We're going to get into 9-2 today. So something new, but not really new. We've done this all year long. What is it? Transformations. Here they are, okay? So we're back into our, I promised you we would do this, up, down, left, right moves, right, as well as our, vertically stretched, vertically compressed, horizontally, all that fun stuff by a factor of 8 to whatever, okay? So again, none of these words really should be new. Vertex form will be new. The very last slide today, I want you to highlight, circle, do whatever, put a Post-it note on it, right? When you get to your bookwork problems, when you get to your quizzes questions, when you get to whatever it is, your homework problems, and they're asking about vertex form, refer back to that last question, okay? Reflections, dilations, translations, those are just our moves that we know very well, okay? Again, if you forget how they all work, there they are. If you've got your cheat sheet, good, pause this video. Write in all of your cheat sheet things, okay? There you go. All right, again, if you forget it, bam, all good, okay? Describe each translation as it relates to our parent function again. F of x equals x squared is our parent function. That's the one here in blue. So how did the green one change? Well, in this case, now look, some of you are going to freak out. Hey, look, you could also write g of x with x squared and 10 second. That would be fine, okay? So obviously, maybe now it's easier to see. This function is translated 10 units up, okay? So translated 10 units up, you write that there. Okay? Same thing here. Blue one is the parent function. This case, h of x. Looks like it moved down. Indeed, I can tell you that it absolutely did. Minus 8 will translate down 8 units. Down 8 units. Okay? Again, f of x, still the blue one, still our parent function. Translated. Okay, remember, we see plus 1 in parentheses with our x value. We're thinking, hey, this should go right 1. It does the exact opposite. This really is a left 1. Right? Again, there's my graph to prove it. Eventually, we're going to take away the graph, and you're not going to have that visual representation there. You're just going to have to know that, hey, when I see this, moves 1 left. Okay? Again, just the opposite here. You can look at our blue and our green graph. Looks like the green one's to the right. It is. By how many units? Well, by this many units. 4 units to the right. Again, that's what a right 4 looks like. Okay? Again, if you get stuck on ones that look like that, go back and use these. Again, hopefully you wrote down all of those answers. All right, now we got multiple moves here. We just have to describe each one. What does that do? What does this do? Okay? So what does the first plus 1 do? Well, it's in our parentheses. This is a left-right move. So this will make it move left 1. Guys, it's the end of the day. Okay? The second plus 1 makes it move up 1. Okay? So left 1, up 1. Again, if I look at the vertex, my vertex went from here to here. Left 1, up 1. Perfect. Got it. All right. Flying through. Describe this translation. So again, I need to describe what is this doing and what is this doing. Okay? Great. All right. So the minus 2 goes right 2. So right 2 units. Again, this makes it go up 6 units. Okay? Right 2, up 6. Beautiful. Alrighty. Alright, now we get to the dilation. So these are our compressions. These are our stretches, all of those. Again, a vertical stretch is the exact same move. It will look identical to a horizontal compression. It just depends on where that factor is. Is it with my x? Is it outside of my x? Okay? All right, so here we go here. So parent function in blue, g of x is that 1/3 x squared. So it's getting less steep. Does everyone agree with me there? Yes, of course you do. I like this. I just stand over here. You can't even see me. Okay? So yes, guys, this one is a vertical compression, right? When we are outside of the x, we're going to use the word vertical. Okay? So vertical compression by 1/3. Okay? Vertical compression by a factor of 1/3. Right? Meaning it will get 1/3 as steep as the other one. The parent function. Let me be more clear. Okay? Right? All right. When we are with the x value, we will use the word horizontal. Okay? Look at your cheat sheet. Right? What is that 2 going to do? Horizontal compression. If you said horizontal compression, you are correct. Horizontal compression. Once again, by that factor of 2. Okay? Fantastic. This is so much fun. Okay, reflections. Again, where is the negative sign? Is it with the x or is it outside of the x? Okay? If it's outside of the x, we're going across the x-axis. If it's with the x, we're going across the y-axis. All right? 2 moves here, folks. First move is the negative sign. All right, the second move is the 3. So what do both of them do? Okay? What do both of them do? So let's do the 3 first. So the 3 is outside of the x. So this is a vertical stretch, right, by a factor of 3. The negative sign, not with the x. So when it's not with the x, we're reflecting over the x. So this does a reflect over the x axis. Sorry for my terrible handwriting this late in the day. Okay? Great. Describe the transformation. So once again, I need to describe that. I also need to describe that. Both of these moves are with my x, right? And it's easy to see because we have parentheses. Okay? So, what do they both do? Again, so this is a reflect over what, people? This is a reflect over the y-axis. Okay? Here, we need to be using the word horizontal, right? If we are with the x, we use the word horizontal. If we were outside, some number out here, we would use the word vertical, right? So this is going to be a horizontal what? Somebody said it, horizontal stretch, right? Horizontal stretch by that factor of 1/2. Okay? Again, identify your moves, describe them. We should be getting very good at this. Okay? More projectile motion, the path of center of gravity, blah, 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 during a leap is modeled by that function. Okay? Function looks different, doesn't it? Huh. Where x is the horizontal distance. Okay, starting point, h of x is the vertical distance. Describe the transformation as it relates to the graph of the parent function. So as always, the graph of our parent function, f of x equals x squared. Okay? So I have one move here. I have another move here. And lastly, I have a move there. Oh, and I got something over here. 1, 2, 3. We have 4 moves. Put them all together. What do they all do? Okay? All right. Well, we can really start wherever. All right. What does this 1.53 do? You got it. That makes it go up 1.53 units. Okay? What does our minus 3 do? Moves it right 3 units. Okay? What does the 0.17 do? This is a vertical compression. Nicely done. Vertical compression by that 0.17 factor. And then what does our negative sign do? I'm glad you asked. It is a reflection over the x-axis. Okay? So again, you have to identify all the different moves, right? Use our cheat sheet until we get comfortable again with these, which we should be getting pretty good, I would hope. Okay? And that brings us, oh, here, by the way, guys, this function right here, this is in vertex form, right? This is not in standard form, is it? No, it is not in standard form. Why is it in this form? We can easily identify the vertex, okay? of that function. It happens to be this y value with the opposite of that as an x value. Okay? Anywho, let's do some more fun stuff. Here we go. All right. As mentioned, anytime they're talking about vertex form, standard form in your book for bookwork questions, any of that other stuff, refer back here. So welcome back. Maybe you're watching this for the first time, or maybe this time. Who really knows? Okay. Anyway, here is vertex form right here. Guys, standard form, y equals ax squared plus bx plus c. This is really the only tough math we have to do today. All right, write a function in both forms, vertex form and standard form. And then they give me some information, thankfully. They've given me a point, and they've given me the vertex. I am home free if they give me that information. Okay? Here is a point. Every ordered pair, folks, has an x and a y value. Right? My vertex has an h and a k value. Okay? All right. Now, I'm not a very good counter. 1, 2, 3, 4, 5. I count 5 variables there. The reason they have to give me 4 of those. Those 4 came from here and there. Okay? In order for me to write this in vertex or in standard form, I need to know what this dude right here is. I need that number. Right? That's my a value, right? That's my leading coefficient, right, for my quadratic function. I need that number. Well, good news. We will find this very quickly. Here is all we need to do. I need to substitute in these x and y values where they go, and these h and k values where they go. The formula will take care of everything else. Then we're going to solve our equation for a. Okay? So if you want to try to do this, plug those numbers in where you think they go. Great. Maybe you did that. Maybe you didn't. What number is y? Well, y is 1. What number is a? It's not. That's what we need to find. All right. X minus h. X value. -4. Minus h value. Be careful. -2. This is squared. Plus my k value, 5. Whew, okay. We can simplify this. Be careful. -4 minus -2. This means plus, plus. So this all turns into what number? -2. Okay? -2 squared is -2 times -2, which is 4. Okay? 4. Done squaring. All right, so now it looks like this. 1 equals 4a plus 5. Can we solve that equation for the variable a? I would think so, yes. We should do what, folks? We should go ahead and subtract 5 over here. 1 minus 5 is -4, and that's equal to 4a. So a is equal to -1. Yes. Okay. All right. So I'm going to write that in here. A equals -1. Look, now we're done. We're literally just going to write here. I'm going to get rid of all this. Make all this go away. Okay. Now we're just going to replace x. No, sorry. No, we're going to replace h and k. Leave x and y where they go. So for vertex form, it's going to look like this. Y equals, a is now the number -1, x minus h, x minus -2, squared plus k, which is 5. Now, clean this up here, folks. X minus -2, we're just going to say x plus 2. Okay? Done. Vertex form at its finest right here. Again, what is the vertex? Opposite of this number, comma 5. So -2, comma 5 is my vertex. That checks out. Okay? Now, if I want to write this in standard form, not that hard. We need to square this first. Okay? Okay, so -1, hang out. So in other words, guys, I want you to FOIL this, right? This just says x plus 2 times x plus 2, doesn't it? So if we FOIL that, that turns into what? X squared. That'll be plus 2x plus another 2x, which would be 4x, and that would be 4, and then this would be 5. Okay? Order of operations, who goes next? Well, distribute negative 1 into everything. So y equals negative 1x squared minus 4x minus 5, minus 4 plus 5. Can you simplify these two terms here at the end? Yeah, we can. Negative 4 plus 5 is just 1. So we'll say plus 1. Okay? So there's standard form. There's vertex form, right? Vertex, standard. Okay? So refer back here if you need help with it. Okay? But that's all we got to do. We have to know what A is first. And we find A, guys, by using our ordered pair they give me, X and Y, and then using my vertex as H and K. All right. Awesome. I hope you enjoyed that. And you guys are great. You didn't have too many questions today, so we should be able to be really good at all of our other stuff. See you.